Okay, ladies and gentlemen, you function mathematicians, I am in between a couple conferences, so I'm going to try to get this video done as fast as I can. I think I have 20 minutes, so that should be enough time. All right, we are going to learn how to solve exponential equations. This was just a funny little thing that Miss Wadley put on there, and I thought it was silly, so there you go. Okay, so let's see if we can get this to go. We already have this in our notes. Check your notes, make sure you have this. We've already talked about it. If you don't already have this in your notes, make sure you do. Otherwise, we've already talked about this. We went through this example in class. I've already covered this. But again, we write each side as a base. I just wanted to quickly go through this because now we're going to do a more complicated case. And then we always want to check our answers. Again, we have already gone through that. So now let's look at this one. This one looks similar, but it is definitely different. We have 25 to the x minus 2 is equal to 25 to the x. So the first thing we want to do is rewrite those as the same base. Because if we can rewrite them as exponentials to the same base, then we know that we can solve for the exponent and be done. So again, I can write that as a 5 squared. 25 is 5 squared, and 125 is 5 cubed. Then we're going to use those rules of exponents and multiply. So when I take 2 to the x minus 2, I'm multiplying, and 3 to the x is multiplying. That's the rules of exponents. That's where that comes back in. That last unit, we're now building on that information. So then now we have the same base. So if we look here, we have this base is the same as this base. So then we can say that 2 times x minus 2 is equal to 3x. Now that doesn't look like a hard equation. We know how to solve that. We get 2, we distribute the 2, and we get 2x minus 4. We subtract 2x from both sides, and we get negative 4 is equal to x. Now what we want to do is we want to plug it in. So if we get negative 4 minus 2, we end up with 25 to the negative 6 and 125 to the negative 4. So the only thing we have left to do is to plug that in our calculator and make sure that they match. They do match, so then it is a true solution. So our answer really is x. So just like the unit before, we need to plug them in and make sure they work. And that's because we're going to have asymptotes, either vertical. This one would be a vertical asymptote versus a horizontal asymptote with an exponential. Oh, so that one would be horizontal, excuse me. All right, so now this one looks a little bit weird. So we're going to look at the 4 and the 32. Can we rewrite those as the same base? Well, we definitely can. I can write 4 as 2 squared and 32 as 2 to the 5th. So then now we want to make sure that they are equal to the same base. So right now we have 1 over 2 to the 5th. But how can I make it so that the 2 is large? So I can make that exponent negative. I can move this, I can move this to the top, and I will get 2 to the negative 5, right? So just like we did before, that's what we're going to do. So now my bases are the same. I've got a 2 over here and a 2 over here. So then the only thing I'm left with is the 2 times x, and we end up with 2 times x is equal to negative 5, and then we get negative 5 over 2. Again, we need to plug that in. And one of the things that I would do here, from this step to this step, is I would rewrite that. So this is saying 1 over the square root of 4, to the 5th power. Why is it not? There we go, to the 5th power. So then that would be, square root of 4 is 2, 2 to the 5th power is 32, and that is true. So our solution is negative 5 over 2. Okay, this one's a bit wonky, I will say. So what I would look at is this 3 first. Okay, so we know we're going to need a fraction. So is there any way I can make the 16 a base of 3? No. Well, what about the 9? Yeah, I can. I can make that 3 squared. So that's 3 squared. And then what about this? Now we have a 4, so 16. Yeah, I could rewrite that as 4 squared. So I'm going to use that idea. So now that I have the same numbers in my fraction, how can I get it so it's exactly the same? So I have 3 over 4, and I basically have the reciprocal. How can I flip this mathematically using exponents? And if you said, if you move this one this way, so we know this rule, if we go down right here, that's 4 squared, that would become 4 to the negative second. And if we move this one up, that will become 3 to the negative second. And we end up with 3 over 4 to x equals 3 over 4 to the negative second power. So this isn't an instance where a negative exponent makes sense because we're solving. So now we have exactly the same base, exactly the same base. Now we can set the exponents equal to each other. And so x is equal to negative 2. Well, that's true. And here's exactly why. If we plug it in right there, we end up with 4 over 3 squared because we want to make it positive to solve. And we end up with 16 over 9. So our solution is x is equal to negative 2. All right, so here is part 2 examples. All right, this is what we just did. 1 and 2 is exactly what we did. We said if x is equal to y, so if the exponents are equal, then b to the x is equal to b to the y. We already know that. We already have this in our notes. We also know if this is true, then this has to be true. We, again, already know that. Now, 3 and 4 is what we're going to talk about. So this says if x is equal to y, and they are positive, then log base b of x is equal to log base b of y. So now we're going to use logs to help us solve, and we're going to use logs to help us solve with the same base. And number 4 says if x and y are positive, then log base b of x is going to be equal to log base b of y, then x is equal to y. So make sure you get that in your notes. All right, so here, we're going to get a decimal answer. So we have 10 to the x is equal to 4. Well, I can't write 10 or 4 in the same base. They don't have one. I can't even think of a base that I could take 10 down to get to 10. Like 1 to the, no, that doesn't work. 2 cubed is 8, 2 to the 4th is, so we skip 10 there, and then 3 is just going to be higher. So there's no number that I can use. So we're going to use log, and we're going to we want to get rid of one of the bases. So let's get rid of this base, this 10. So let's do log base 10 on both sides. So I have, remember when there's nothing, there we go. When there's nothing written here, this is log base 10 is equal to log base 10. Okay, then we're going to do the power rule so we can get the exponent out front. Now, this says log, I'm going to write it in, base 10. What did we learn? It looks like a 6. Hold on. 10. So what did we learn the other day? Well, we learned if these are the same, if we have log base 10 of 10, this actually just turns into a 1. So it cancels out. And if it cancels out, we are left with x is equal to 0.6021. Well, let's check that. That's what x equals. We take it, and we do get a number pretty close to 4. It's approximately 4. It's like 3.99 something. I'd have to plug it in to look for sure. So that is our solution. Now we have e to the 0.02x is equal to 192. Well, I want to get rid of that e. Big thing we need to remember, this e, not a variable. E is not a variable, e is a number. E is a number just like pi is a number. So we need to remember that. E equals 2.718281828, 459045. So if you put e, if you hit second, and I think it's second in your division key, that'll say e, hit enter, you will get a number. So we need to remember that. And natural log undoes e. So we're going to take the natural log of both sides. So when we take the natural log, and then we're going to do the power rule, and we have this power rule right here. So then we have the natural log of e, and if you plug that in your calculator, so something that we need to remember, the natural, oops. All right, let me hit pause really quick. Okay, so if we have the natural, here we go, see if I can get this written down. Okay, the natural log of e, and this is something you'll use a lot in calculus and in pre-calc or trig, is equal to 1. And remember, log of 10 is equal to 1. So we need to remember those properties. So if we know that this is a 1, it cancels out, it turns into a 1, and we're just left with 0.02x is equal to the natural log of 192. Well, now how do we get x by ourselves? Well, we divide both sides by 0.02, and guess what? That's what we get. And if we plug that in our calculator, we get about 263. We will always tell you what to round to, so you don't have to guess, but this one is about 263. We're going to plug it in. It does work, so that is our answer. So the last thing I want to cover today is just kind of, I want to do a recap or a generalization. So what we want to do is to take logarithms to the same base on both sides and then use the power rule or use a special property rule to solve. As a special case, if both sides can be rewritten as exponentials to the same base, we should do so, and then we'll set the exponents equal to each other. So we just did a couple of examples of both of those. Make sure you get them in your notes, and tomorrow we'll move on. I hope you all have a great night, and I will see you tomorrow.